Okay. So the domain is x must be larger than 0 because the denominator is there's a square root, right? So all the values that make g of x undefined, those will be 0 or less, 0 or less. So let me write it down. Okay, so A. Okay, the A we have simplified, right? We have simplified, and that's simplified A. Okay, I'm gonna put A over here. Okay, and B. It just set it equal to 0. Okay, so when we do this, we create this if statement, right? So if g of x equals if g equals to 0, g of x equals 0. This is creating a if statement, which is set up an equation, Okay, then if g of x equals 0, this piece cannot be 0. So the only piece that can be 0 is this guy equals to 0, right? So that's the narrative. That's a narrative you want to, you know, put together. And of course, x equals to 1 or x equals to 2. X equals to 2. Okay, and C, and last but not least, is that you basically determine the domain. Okay, the domain would be x larger than 0. And the place where g is not defined, right? Values that g is not defined, will be the opposite, will be x less than equals to 0. Okay, when you're in calculus, class, what you will learn is that there'll be other definitions you're going to have to apply. So you may end up just have, just to have 0, x equals 0. Okay, so I'm not going to dive into that. Do you want me to go over number 4, or shall we directly get to number 5? Or you think you guys can handle them all?
Can you do number 4?
Sure. Let's look at number 4, right? Number 4. Okay, so that's a task from yesterday. Let's do them together, okay? So that way, so this is 5. Let's look at number 4. 4, we have g of x equals to 2x multiply 4 minus x to the power of sorry, I'm pressing the wrong button, to the power of -12. So you may wonder why we have these, negative exponents, right? Once you get to calculus class, you understand you have all these functions. When you take a derivative, applying the power rule, and then you're going to sometimes generate those negative exponents. Okay, then you have to reduce it. Okay, hold on. I'm going to check it. little chilly. All right. And okay. In this situation, obviously, this guy has, this is a 4 minus x to the power of, this is a 4 minus x to raise to the power of half, right? So it's a different way of writing it. The rule of thumb, okay, so I want to give you the rule of thumb of how to reduce these kind of functions. The rule of thumb, you look at the lowest exponent, okay? So which one is the lowest exponent? Negative half, right? Negative half. So you're going to factor out the one with the lowest exponent. So what you're going to do, okay, so let me show you. Over here, you have the lowest exponent on 4 minus x. On the other one, you don't have it, right? We don't have it. That's okay. We can create one. We're going to create one. We're going to have this guy multiply that creating a power 0. You guys see this piece? Everything else stay the same, right? Everything else stay the same, but this piece I created, and what is it? It's 1. It's a 1, right? How is it a 1? Because this negative 1/2, positive 1/2, and the base is 4 minus x, right? So when you combine these two, when you combine this product, when you multiply these two, it's going to be 4 minus x is the base, and the exponent will be adding, right? When you're adding the exponents, negative half plus half is going to be 0. Anything to the power 0 equals to 1 if the base is not equal to 0. Does that make sense? All right. So this is by doing this rule of thumb, I would say it can carry you for quite a while. It works in most of the cases you're going to deal with. Okay. So what you see is you're going to have a 4 minus x raised to the power 0, because that 0 is created by a negative half plus positive half. Okay, so that's going to be, let me make the fonts a little bit smaller, 175%. Okay, so this is going to give you a 4 minus x raised to the power 0. So this piece is a 1, provided that 4 minus x is not 0. And of course, we are going to guarantee 4 minus x is going to be, larger than 0, because square root 2 is a root, right? It's a root. So relate that power with the root, okay? All right, so that's how we create that situation that we're going to factor out, okay? So we're going to factor this piece out. And now we have it, right? We have this piece. So this piece is factored out, right? This piece is factored out. And then what's left inside, right? Over here, you have 2x minus 3 times that, right? 3 times that. And this piece is out. So you have this other piece. Are you with me? I know when you see, when this is omega, is much easier to see, isn't it? Our omega, of course, is 4 minus x. All right. So you're going to have lots of these situations. You have to be able to recognize that. And what's this guy? This guy, okay. So let me put a note on the side. Okay, so these two pieces, okay, to help you see better. Okay, if I put it on the side and I tell you this is omega and that is omega, right? So this is really what? This is really just a square root of omega multiply another square root of omega. Okay, do you see that? And what is that? It's omega's the square root of omega squared. That's what it is. Do you follow me? Everybody? So the way it's written like that, I know it could just really throw us off. Okay, really throw us off. But if you look closely, this is just the base. This is just the base B. This is just the base B, or you're more used to it, base B, base B, base B, right? Or you can just call it, I don't want to use X because we already have X over there, okay? So, and when you, so this is what we meant that those ABC, XYZ you learn in algebra classes, sorry, this is the wrong place. They turn into baloney. They turn to baloney. Oh, sorry. Okay, hold on. Let me just write it down properly. Okay, so this thing, time itself. That's what it is. Okay, so that's just 4 minus x. This is just root of 4 minus x. Do you see that better? So what does it equal to? It equals to 4 minus x. Okay. So now with that being done, we continue the simplification. And then we have the bracket over here. We have the 2x here minus 3 times 4 minus x. All right. So can we simplify that? Of course, right? We can simplify that. Okay, so 2x minus 12 plus 3x, right? Minus 12 plus 3x. So in the end, we got that. That's 5x minus 12. And you can change it to parentheses if you wish. Do you want to try that? I want to give you a couple minutes to try that. Okay, you really, really must do it yourself. You really, really must do it yourself. Okay, by watching, it's not enough. You have to watch, you have to do it. Okay, so what I'm going to do is that I'm going to leave it on the screen. Okay, for those of you who have, who have done this, you can go ahead and do number 5. Okay, we'll do number 5 together. Number 4, Okay, I want you guys to get to these details and get it done. In actuality, okay, when you are taking that class, as you're getting better, you don't need to show this much work. You really don't need to show this much work. Like in the textbook, right? In the textbook doesn't show this much work. The textbook probably just show you 3 steps maximum. Okay, the textbook will probably go from here and they get here directly. They're gonna skip the 2 steps in the middle. But that's the part we are filling in together. Okay. And they give you 3 steps. 1, 2, 3. That's it. That's what they show you. Right? That's what they show you. So I'm gonna leave this on the screen. Okay, I'm gonna leave it on the screen and you try it. You try it. Okay, don't look at the screen. Okay, don't look at the screen. And I'm gonna set up number 5. I'm gonna set up number 5. Number 5 is cubic root. Okay, cubic root. Okay, hold on. I'm gonna grab my teacup. I'll be right back. All right, did you get it? Did you guys get it? Is it getting easier?
I have a question, Professor.
Yes.
I did number 4 in a different way, but I don't know if it's correct.
Oh, please, would you like to show us?
Yeah.
I would love to see it. Yes, there are more than one way to do this for sure. Absolutely. So please send it. You certainly can do it a different way, of course, right? Remember at the beginning, I show you 2 ways, right? I show you 2 ways. One is you get to the form you're familiar with, and the other way. So let's see what the other way has been done. Let's see. Great. Thank you, Andy, for sharing that. Let's get to it. All right, that's okay. Thank you, Andy. Let me make this fonts just a little bit larger. Does everybody see that?
Just forget the stuff on the right, the little stuff on the right.
What little stuff on the right?
That's 6x in parentheses 4 minus x right there.
6x. Which
Yeah.
6? Oh, here. Oh, you want me to ignore that?
Yeah.
Sure. Yeah, sure. So let's look at Andy's work. Okay. So he wrote it down this way. Okay. So I'm going to put some marks here. That's correct. You know, the equal sign. That's good. And then he made the 1, right? He just used a different form, right? Root of 4 minus x divided by root of 4 minus x, right? That's good. And then with the common denominator, and he got that. And this is 1 times 1. That's good. And you can just remove the 1, but that doesn't affect anything. That's all good. This is all good. It's perfect. You can do it this way. Yes, you can do it this way. This is a good job. Okay, I ignore that 6x times 4 minus x for sure. Very good job, Andy. Yes, you can certainly do it this way. Okay, you can certainly do it this way. Okay, thank you for sharing that. Okay, did you guys write it down if you wish? Because this is the familiar form. This is the familiar form. Okay, the other form, you know, you learn in time. You learn in time. Okay. All right. So let's go back. And the rest of the steps. Okay, let's look at the rest of the steps, right? So the A is done. And let's look at B, right? If you like it this form, some people like it this form because it has a clear separation between the numerator and the denominator. Okay, so it's a 4 minus x over here. Okay, because we're more accustomed to see this form. So when we are to decide, so on the B, right, we're going to create an if statement, right? So if g is 0, if g of x is 0, right, this is a g of x. If g of x is 0, So we are creating a if statement. We're creating an equation. Okay. When we're creating that equation, the denominator cannot be 0, right? If then the numerator must be 0. Okay, so 5x minus 12 must be 0. And of course, x is equals to 12 over 5. Okay, so that's the value that it costs g equals to 0. G equals to 0. Okay, let's look at C. Right? C is to find values such that G is undefined, right? So which is the opposite of domain in our situation, right? So you first find domain. Okay, so how do we determine domain from G? Right here. 4 minus x must be greater than 0. Okay, 4 minus x must be greater than 0. And the consequence would be that, will be what? Will be x is less than 4. Right? So values where G is not defined is undefined. That's going to be the opposite of it. Okay, the opposite of x less than 4 is what? Is x larger than or equal to 4. Right, so for now you just do that. That's fine. Okay, in your calculus class, you're going to have to incorporate other definitions to make your other decisions. Okay, so that's, I'm going to leave it for your calculus class professors. Okay, number 5. Are we ready for number 5? Number 5, it's a little more even more complicated. It's even more complicated. It's even more complicated at 2 levels because you're going to have to factor it out. You have 2 bases now, here, there. If you look at the form I give you on the side, right? So let's put it, let's work on a note, or maybe think out aloud. Right? So how do we simplify this guy? Right? So here's the x. So I'm going to imagine this is just a omega. That's omega. Right? So my omega is x minus 1. Right? It's x minus 1. And then how do I reduce this form? How do I reduce this form? Well, one of the things I can do, I can take out the denominator 3, right? Right, so we do it a little bit at a time. So one of the things we can do is that, hey, I'm going to take out the 1/3. That might make my life a little bit easier. Okay, so I have this guy, and I have 2 times of the other one. Rule of thumb. Okay, so I'm going to show you how we use the rule of thumb. The rule of thumb, you want to factor the piece with the lowest exponent. But we have 2 pieces with lowest exponent, right? One with base x, the other one with base omega. So you want to factor out these 2. You follow me? Or do you want me to do the other form? Do the familiar form first. Okay, so let's do the familiar form first, okay? This is a root, I'm gonna write them not only with omega in place, and we're also gonna write this as cubic root. okay, cubic root. And we're gonna write all of these as cubic roots, okay? So this is gonna be cubic root of x. And this one is a cubic root 1 over. Okay, that's omega. So you can put this guy on the top. How's that? This piece is a cubic root of omega squared, cubic root of omega squared. Cubic root omega squared. And that piece is always under. Okay, cubic root, sorry, cubic root of x squared. Do you want to work with this form? You want to work with the other form? So let's do this form first. Okay, let's do this form first because this is our familiar form. This is our familiar form. We basically want to make a common denominator. Okay, we want to make common denominator. Shall we put x minus 1 back where it is? We probably can, right? In this case, we can. Let's do that. Let's do that. Okay. So let's just do that for now. We're on scratch paper, so we can be very liberal, right? We can make some changes, but any change we make, we must make sure it is consistent. So even when we come back for ourselves, we can check the work, right? So do you guys agree with these changes, right? This guy goes here and that guy's stay on the top. And this is 2 times, okay, 2 times, okay, cubic root of x and excuse me, cubic root of x minus 1. So next we're gonna make a common denominator. Common denominator. How do we make that common denominator? These two are different, right? So it's like, how do you make common denominator out of this other situation, right? You have a over x plus b over y. Okay, so let's not use xy, use uv. How do you find common denominator in this situation? The common denominator is u times v, right? So this is our u and this is our v, right? We know how to do this, right? So you're gonna make the common denominator like that, right? So this is gonna be, this was u, this was a, and this was v, and that was b. And now you want the same common denominator. What would you do? That you're gonna have to multiply v over v on this side. You're gonna have to multiply a u over u, yes? Is that right? And your u, v are these, u, v, a, b. Do you see that? Okay. So we have learned this. We have learned this. It's just in a, what we learned was in simpler form, They're already, simplified for us, for our beginning algebra class, intermediate algebra class. And then all of a sudden in calculus class, boom, these things show up in front of us. Of course, you find these algebra weird, right? All right. But you can do it. Okay. So with that guideline, right? So I'm going to take this piece. I'm going to multiply. I'm creating that one. Okay, so that one is the V over V. And the other piece, I'm creating that situation. Do you follow me? So this is one. Okay, so this is one. And that one is created by taking the other denominator over the other denominator. This is one. And this one is created taking this guy as the numerator and the denominator at the same time. The whole process we're operating this is providing that we are in the domain. It's not an issue at all. Okay, so we got the UV. And then what do? You must write it down, everybody. You're in the class, you must write down what I'm writing down on the screen. Otherwise, it's very difficult to follow. How do I know that? Because I was a student before. Or even today, okay, I watch someone doing math. If I don't use paper pencil, and I will be lost after 2 steps. Especially something like this, okay? So please have your paper pencil. You write down and you make sure you understand what you write down. If I'm too fast, just slow me down. If I'm too slow, tell me to hurry up. Okay, there's a chat, right? You never offend me, okay? Your interaction is, your feedback is always appreciated. So don't worry about that. Okay, so I keep my chat open. If you need me to slow down or speed up, let me know. So now we have the same denominator. I still leave the 1/3 outside. Okay, just focus on the inside. Let's look at the inside. The first term, now we have the common denominator, U and V, U times V. And what's on the top? On the top, you have this guy, multiply that guy. Plus, okay, so I'm just going to put them together. Okay, I already got the same denominator. And the numerator, we're going to take care of the numerator. I'm sure you're going to be so delighted. You're going to be so delighted you have those. Okay. Do some of you already see it? Look at this piece and look at that piece. The 2 should be in the front. Okay, sorry. The 2 should be in the front. Okay, 2 put in the front, right? I put this 2 in the front. And what are these 2? These both are √3. So I can bring them under the same √3. Can I? Okay, so let's do one more step. I'm going to bring these 2 under the same roof, √3. Okay, so I'm going to bring this x inside here. And x squared times x, that's x raised to the power 3, isn't it? Oh, sorry. Power 3. Oh, sorry. Sorry about that. You follow me? So these 2 in product combine into this. What's that? That's x. That's x, right? Remember? Three x raised to the power 3. Okay, or root 3 they are always the same. Power 2 do you guys understand? We address these issues, right? That equals to x, but root of x squared equals to absolute value of x. This is always true. If you have any doubt, any questions, I can go over it. So this guy is what? This guy is x. How about this piece? We have a similar situation. Okay, they're both root 3, and this is x minus 1 to the power 2, and this is of x minus 1. So if we combine these two, what do we get? We get power 3. Yes? You get that? Now, the next step. Okay, so this is going to be x minus 1, and this is x. Right? So by this time, any questions? Any questions? By this time, okay, I'm waiting for you guys to write it down. Because I can do copy and paste, and you have to write it down. Okay, you must write it down, please. Okay, you must write it down. So now I have the same denominator. Okay, I'm gonna keep my 1/3, multiply. Now I have the same denominator. And the numerator, I would just have x minus 1 plus 2 times x. In the end, okay, 2x plus 1x, that's going to be 3x. 3x minus 1. So that's the final g. That's a lot of work, isn't it? You will get better. You will get better. I will show you. I will show you the other way. Okay. So, do you want to take your time to go over these by yourself? Well, when you're in calculus class, I will not be holding your hand. You have to do it yourself. So you better do it now. If you have any questions, you can ask me. Your calculus class professor probably will go over with you, but he doesn't have this much time.
I have a question, Professor.
Yes.
How'd you,
Yeah.
when you got the 2, you factored out the 1/3?
The fact that 1/3 was factored out a long time ago.
And that's how you got the 2?
Yeah. You see 2/3, 1/3. 1/3 is out, so you have a 2 left.
That's not 1/3?
No.
Oh, never mind.
2/3 is 2 times 1/3. So 2/3 is out. You see?
Okay. Got it.
Right? So got it?
Yeah.
Okay. Can you guys, I'm gonna record the lecture a bit longer today because I was late by half an hour. Okay. But if you have to go, you can go and you come back to watch the recording. because I know you might have another lecture. But if you can stay, I'd appreciate it. But it's really my fault. I was late, so I will make up for that time. I'll make up for that time. Okay. All right. So, any questions along the way? If we understand these steps, right? If we understand these steps, I will show you the other way with the rule of thumb. Okay, you might like the other one better. You might like the other one better. Okay, are you ready? Okay, so when you watch, you can watch the recording if you wish. Okay, so suppose I'm doing this the other way. Okay, so this think out aloud, this is just you know, one way. Let's do it the other way. Right here. The other way, when you apply the rule of thumb, okay, I'm going to show you how you do that, right? You know you're going to factor this out, and you're going to factor that out. Because these are the two factors with the lowest exponent. Do you follow me? For the specific base. We have two different bases. We have two different bases. Okay, we have two different bases. So first, I'm going to give you a short version of this. I'm going to give you a short version of this. Okay, the short version I like to show you is this. Okay, so I'm going to have it here, and I'm going to treat this as omega. Okay, so I'm going to treat this guy as omega, right? Like we did earlier. This is omega. So hopefully that's simpler, right? Where my omega is x minus 1. And next, okay, knowing I'm going to using the using the rule of thumb, you know you need to have this, right? So you have this guy, but you don't have this guy in this expression, right? So what you're going to do is that you're going to make it. You're going to have omega to the power of 1/3 multiply omega to the power of negative 1/3. So what am I doing here? I'm creating this guy times that, which I'm about to factor them out. Do you follow me? So this piece, what is this piece? That piece is 1. Do you see that? This piece, okay, let me mark this piece. Do you guys see that? That piece, hold on. That piece, oh, I'm sorry, I hit the wrong place. That piece is 1. Because it is omega raised to the power 0. You see that? Omega base, power 1/3 plus negative 1/3, that's a 0. You see that? Okay, why do I do this? Because I want to have this guy and that guy. That's the two pieces I want to factor it out. Okay, the next piece. For the next piece, I have this guy, but I don't have this guy, right? I don't have this guy. So what I'm going to do is I'm going to have to create it. Okay, I'm gonna have to create that x raised to the power of negative 2/3. So if I need this, I need this one. I need this one in here. Okay. But I cannot just put it here without balancing the equal sign. So I'm gonna multiply x raised to the power of positive 2/3. So this piece, once again, is 1. Do you see that? And how is it 1? And that is the x raised to the power of 2/3 minus 2/3. And that is 0. That's 0. And x raised to the power 0 is 1. Do you follow me? Yes? Do you see that? Now, does everybody follow me? So what I have done here, I have created a 1. This is a 1. Okay. I'm going to put it on the side. Okay. And this piece is also 1. So if you look at what we have here, it's exactly the same as the top, isn't it? All right. Because this piece is omega to the power 0 equals to 1. And that other piece, right, that other piece, which is x raised to the power of 2/3. Does everybody follow me? Am I too slow?
This is a good speed.
Huh? This is a good speed. You follow me, right?
Yeah.
So this is the number 1, and this is the number 1. And this is my number 1. Anything times 1 stay the same. You follow me? Anything times 1 stay the same. Got it? And this piece is 1. Now, okay, I'm going to put away all of these stuff. Okay, I'm going to put away all of these stuff. Okay. These are done. Okay. Remove that. Remove that. So I'm going to factor it out 1/3. I'm going to factor out this guy. I'm also going to factor out this guy. From both terms, right? So this is out, this is out. And what's left on the first term? This guy. On the second term, 1/3 is out. So we have a 2 here, right? This is out, this piece is out, and that piece is out. Right? Do you see that? The same pieces are out. This piece, right? Right here. And that piece is out. So what I have left is x raised to the power 2/3 multiply x to the power 1/3. Okay, you follow me? With √3, You don't have to worry about root 3 of x to the power 3 equals to absolute value. It's always equals to x. Root of x squared equals to absolute value of x. You follow me? You know what I'm saying? Okay, that's what we wrote down earlier, right? Root, I wrote it down somewhere before. Yeah, here, right? That's what I meant. Okay, so now what do we got? This is what we got. This piece, you have the base omega 2/3 plus 1/3. It's just going to be what? It's just going to be omega. X raised to the power 2/3 multiply x to the power 1/3, 2/3 plus 1/3. That's going to be just x. You follow me? Now, with that understood, you just have to replace omega by x minus 1. You see that? You could have done it with omega in place, with x minus 1 in place. Okay, so you just have to replace omega by x minus 1. If you feel more comfortable that way, oh gosh. Oh, come on. Sorry, I need to do something here. Okay, so this is omega. So this is x minus 1 raised to the power of 1/3. Okay, and this piece is omega, which is x minus 1. And this piece is omega, which is x minus 1. I'm sorry about this. Okay, I'm sorry about this. Hold on, remove that. That's going to make it better. You follow me? Do you follow me? So when you watch this, you need to watch it again. You know, you just have to replay those things, right? And then if you put it in back, you don't have to introduce omega really. You don't really have to introduce omega. As you're getting better, you don't need to introduce omega. I introduce omega here is because I hope, well, I think it might be easier to understand it for the first time. Okay, so now you can put that in place. You can put that in place. Okay, so let's look at this method. The rule of thumb. Okay, the rule of thumb. The rule of thumb is you factored out the lowest the term with the lowest exponents. Okay, this is with the lowest exponent, and this is the lowest exponent. So you have to create that lowest exponents in both pieces. You have 3 pieces, you have to create that in 3 pieces. Okay. In order to create that, you have to make 1, because anything times 1 stays the same. Do you follow me? Anything times 1 stay the same. Because you want to maintain that equal sign. We want to maintain that equal sign. And we created another 1 just for this guy, for that guy, to be both present. Okay, do you guys see that? These two, this is to be factored out. Okay, and this to be factored out. But this one doesn't have that, and that one doesn't have this. It doesn't have this, so you have to create those. But once you created that 1, you're set. The rest is easier. The rest is much easier. You guys see that? Does everybody follow me? Okay, so the rest, if you like this method, this may be shorter because you don't have to write all those roots. You know what I mean? You don't have to write all those roots. You still should get the same results, of course, right? So these with negative roots, oh, I'm sorry, with negative power, okay, with negative power, right? And then the rest is you just get 3x minus 1. But you need to remember, these are in the denominator, okay? These are in the denominator. And so to still transform into the form you're familiar with, even though it's not totally necessary, you have to write x 3 times x raised to the power of 2/3 and over here, x minus 1 raised to the power of 1/3. You just need to understand they are in the denominator. And denominator cannot be 0. Denominator cannot be 0. This is something I would say 99% our students have a difficult time with. Oh, that's part of the reason I want to make it like topics in this class. You follow me? The roots issue, the roots issue. So you have the trig issue, logarithm issue, exponential issue, also the roots function issue. And then this G is already simplified. It's in factored form, right? So on the B, you're gonna say, okay, create that if statement. If G of X equals 0, right? So that's G of X, this is our G now, right? This is our G now. If this guy is equals to 0, right? The denominator cannot be 0 for sure, then numerator must be 0. Numerator must be 0. So 3x minus 1 must be 0. Then x equals to 1/3. All of these exercises, I put it in this section. They are all from calculus text. Okay, so I went in there and I took derivative and then I put the questions, just the algebraic part for you to do. Okay, did I take the derivative correctly? I thought I did. Okay, and 99% of our students just have a hard time handling this. But now you got a tool, you got a tool. You got the rule of thumb, right? And you also have the conventional tool, like you just work with the root node, with the root symbol. Be aware that, okay, this highlighted part, this part I highlighted, it's very, very important for you to understand. Okay, it's very, very important to understand. Okay. So let's finish this one. Let's finish one. I'm gonna address this one more time. Okay, let's finish that one. C. Right? What are the domain for G? What are the domain for G? You see, in the denominator, we have two factors. One is x raised to the power 2/3, and the other one is x minus 1 to the power 1. So neither one can be 0, right? So the values and G is defined in the entire domain except the points that make the denominator equal 0. So here, this is pretty straightforward. Values where G is undefined, Okay, values where G is undefined is X equals 0 or 1. Okay, these cannot happen. X cannot be 0 and X cannot be 1. All right, so these are the two zeros that G is undefined. So let's go back to address the simplification part. You can see these facts are basic facts, and you get to use them all the time, don't you? We get to use them all the time. So I'm going to bring this up to explain to you why it's so. We already know most of it, right? We already know most of it. Are you going to encounter root 5? You might. Remember the first question we did in this section is about root 5, right? The first section you have is about root 5. And so for that one, we understand this, these two, we have explained, right? These two, right? Back to the basics. Back to the basics. These are the basics, right? The difference between these two, we understand, it's a domain. By writing this down, we have implied, okay? Implied. X is larger than or equal to 0. That's implied. Then you say, why do you imply? Why couldn't you say that explicitly? Well, that's a domain range issue. That's a domain range issue, right? We talk about this, it's order of operation. So the domain for this guy is X greater than or equal to 0. So that's why this is true. For the latter one, okay, X can be any real number. X can be any real number. That's the difference. For cubic root, however, it doesn't matter. Positive, negative, you can try them. This will work all the time. For any real number. For any real number X. So this is true for any real number X. Right? So that's the cubic root. Remember we have a root function, cubic root function in table in basic 1, right? That table, there's a cubic root. What's the domain for that? All real numbers. All real numbers. If your X is positive, your X is positive here. If X is a negative, it comes out a negative. It's always true. If it's 0, it comes out 0. And these turn out to be really basics for you to be able to handle these situations. Do you guys see that? You have the basics and you also have the reality. Okay, you also have this reality. Right? You have this reality. Basics, reality. That's going to be your reality in Calc 1. But if you get over now, you're good. You'll be really just one stride ahead a lot of your classmates. I mean, one stride. I hope you don't see that, but you might see that. You're going to see a lot of your classmates in Math 190 struggle. I mean, struggle with handling this. Okay, so if you don't want to be in that situation because you have all these other theorems to handle, right? To understand, to apply. It's a whole new game. It's a whole new game. You think algebra is hard? Wait until you get into calculus class. So we're just trying to make the ground a little bit smooth, you know, a little flatter. All right, so that's basic 46. That's basic 46. If you want more practice, which I really encourage you to practice, but we don't have a whole lot of time to do it in this class. Okay, you look at 46B. 46B, those are the questions, as I told you. Okay, I basically open up the calculus textbook and I pick out some questions I have assigned to my student, and I took the derivative and I get to this point. I let you simplify from easy to simple. So all the types of questions you have seen here in 46A, you will see them there in various forms. I trust that as you do one by one, you are getting better. You're gonna get way better. You're gonna be ahead of the curve. But if you don't do it, this is something that you have to do it yourself. Nobody can substitute you. Nobody can replace you. Mom and dad cannot replace you. Your teacher cannot replace you. Brother cannot replace you. Your sister cannot replace you. You just have to do it yourself. Right? This is one of those things in life you have to do it yourself. Right? Like push up. Right? Okay? All right. I plan to run up to 10 o'clock. To 10 o'clock. I appreciate if you stay. If you want more practice, right? You say, hey, I actually, you start to like this stuff, and there you go. I have 46C and 46C. So you have ABC to practice. Those are unfortunately, realistic questions from calculus classes. Realistic questions in calculus classes. Okay, those are realistic questions in calculus classes. All right. Tomorrow I plan to do something else with you, but today I want to continue to do something with you regarding something we call piecewise function. Piecewise function. Okay, so we're skipping something in between, like 47, that's a root function shifting up and down. And you guys, you guys are able to do it. I trust you. If you have any questions, but please don't hesitate. But I really want to take you guys to basic 50A. And some of those, and 51A, these are called piecewise functions. These functions, what I found is that when I was teaching calculus class, my students just have hard time. They lose easily 20 points, 30 points. Okay, so I decided I'm gonna go over these with you in class. Okay. It's how to handle piecewise function. How to handle piecewise function. What is a piecewise function? Okay. Surely your professor will handle this with you, but it seemed that most of the professors assume you already knew it or you learn it very quickly. It turned out to be not the case. Okay, it turned out to be not the case. Our students need a little bit more time. Okay, we need a little bit more time. So this takes us to basics 50. Piecewise function. Piecewise piecewise functions. Okay, piecewise functions. The simplest piecewise function is the first example. Okay, the simplest piecewise functions is first example. Okay, then you say, hey, we learned function. We learned basic one, right? Basic one table, we put all the basic functions, simple functions. And based on that, we built other functions by composing, adding, subtracting, multiplying, dividing. And what is the piecewise functions, right? Piecewise functions basically tell us in different part of the domain, different part of the number line, the rules are different. Okay, for example, take this one for example. I'm going to use this first example. Okay, the first example I have here. One column, two columns, right? Is 1, 2, 3. And there's an if statement. If x is less than -1, and the second piece is if -1 smaller than equals to x and x is less than +1. The last piece is if x is larger than or equals to 1. You're going to be in contact. You're going to be seeing these functions before you take a derivative in calculus class. Before you see questions on such as basic 46A, the one we just did. You're going to see this almost at the beginning of the semester. The professor probably do a little bit of review and then they jump right in. Then you can start to see piecewise function. So you must understand piecewise function. Okay, so what does this mean? Right? Piecewise function is not new to us. You actually have seen it before. And what is it? Remember f of x? Remember that absolute value x we have done before? That's a piecewise function. Remember the narrative? The absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite. This piece is a piecewise function as well. Okay, the absolute value of positive number was 0, right? If x is greater than equal to 0. Opposite of it, if x is negative. This is a piecewise function, which we introduced to you a long time ago, right? Long time ago. And these two are similar. You just have one more pieces, right? So let's review what we did there. So this piecewise function is very important. This piecewise function is where a lot of our students in calculus class, they lose 20 points minimum. They don't know how to handle it. Okay, so that's why I put it the first thing in the semester, very first thing in the semester, soon we get into the semester, we got in touch with them. So are you better at this now? Right? Now a whole semester has passed. What is expected of you? You are expected to master this function and its variation. To master this function and its variation. We're going to talk about the variations of this function later, but now let's review what this means. And then we get to this one, okay? Then we get this one, okay? We'll get to them. Now, on this function, it's a piecewise function. And what does it mean as piecewise? If you graph this function, right? If you graph this function, you can easily get the graph. It's a V shape, right? We all know that. We've done that, right? It's a V shape. How is this two pieces, because these are two different rules. This is the V shape, right? This is the V shape we're all familiar with. But this is also a piecewise function. Okay, so let me bring it to a size that's manageable. Right? There's a two piece. This piece is y equals to x. And this other piece is y equals to negative x. And there's a 0. 0 can go either side. Every calculus class has to cover this function. Every calculus class has to cover this function. It doesn't matter which language you learn it. Okay. You say, why? Why? You will learn why in calculus class. Because this function is very special. It makes an important point about differentiability and the continuity. The two very key concepts in calculus 1. So these two pieces, you can see the rules are different. The rules are different, right? This piece of rule apply only to negative input. Negative input, for example, right? If the input is negative, right? If the input is negative input. Okay, hold on. When input is negative, we apply this rule. When input is positive or 0, we apply this other rule. This is the essence of piecewise function. Two pieces, right? On this piece, this rule applies. On this piece, that rule applies. So the entire number line is divided into two pieces. So that function we have is two pieces. Okay, and you need to know this function. Okay, so now let's look at before we see the variation of this absolute value thing, how it applies to different situation. And I want you to see the other function. Okay, the first example in this section, this guy. Okay, so we don't need this, it's just repetitive. How about this function? Okay, on this function, this program doesn't graph it. I have to do the work. We have to do the work on the paper. I want you guys to have a piece of paper. Let me have a sip. Have paper pencil with you. You see, this function divides the entire number line into three pieces. Less than -1, between -1 and 1, including +1, greater than or equals to +1. So if I put a number line in place, right? So let me set up the rectangular system. Okay, if I set up the rectangular system. Okay, so please, you guys set up the rectangular system. Okay, there's three intervals. There's three intervals. There's three intervals. What are the three intervals? The intervals, okay, one interval is less than -1. Less than -1. Okay, so I'm going to use the color blue. Less than -1, not including -1. Okay, not including -1. You see how it's being constructed, right? not including -1. That's one interval. Under that in that interval, the rule is, what is the rule? The rule is if any input is less than -1, the output is 1. The output is always 1. Okay. Wait a second. I need to make some adjustment because I just realized this rectangular system. I need to make some adjustment. Okay. Hold on. So I'm gonna make this 5. Okay. So now 1, 2, 3, 4, 5. So that's the rule. And I want you to see the whole function here. Okay. So we have 3 intervals here, right? And the first interval, of course, is the blue line, right? All of these. That's the first interval. And when the input is less than -1, the output is all 1. So the output is 1. For that input, you get a 1. So this is going to be a straight line. And here. Okay. It ends here because at a -1 is not defined by this piece. Okay, between -1 and +1, including -1, is a different rule. And that rule is going to be between -1 to +1, including 1, right? The rule is going to be like that. Okay, the output will all be 2. Okay, I can now erase these. Okay, see, not including -1 on the first rule, and on the second rule, it included the +1, including -1, and it does not include the +1. So on the second rule. The third piece is x greater than equals to 1. That rule says, hey, the output is going to be all 3. So the output will all be 3 forever. And there will be a dot over here. Okay, so this is the function for f of x equals to 1, 2, 3 in these different intervals. And you can see we have pieces, right? How many pieces we have? 1, 2, 3, 3 pieces. Each interval specified by the rule, and that's called piecewise function. That's called piecewise function. Every piece of interval on the number line, the function has different rules. If you look at the domain for this function, what is a domain? The domain is actually all real numbers. Because the function is defined everywhere, right? No number is spared. Every number is spared. How about range? How about range? Range, you only have 3 values. Right? Because that's only 3 values you have. And how about the graph? This is how the graph looks like. This is how the graph looks like. This is called piecewise function. Now, if you compare this graph with the one we just graphed, absolute value, then you know what it means, right? You know what it meant. And this kind of function is called piecewise function. You will have to handle piecewise function, okay, in calculus classes from the very start, from the very start. Now, so we look at basic 50A. I would just go like maybe some 10 more minutes. Okay, 10 more minutes. Okay, we did number 1, we did number 3, right? Let's look at number 2 and number 4. Let's look at number 2 and number 4. Okay, tomorrow we will continue this and we're gonna focus on the variations of absolute value function. Okay, that's the piece that people lose 20 points easily. At least 20 points. All right, so did you take notes? All right, so I'm gonna put this away and let's see how we're gonna handle that piece, number 3. Number 2, sorry, number 2. Okay, number 2 is a function that we have 2 pieces, right? So f of x, 2 pieces. One is e to the power x. Okay, if x is less than equals to 0. Okay, and the other piece is negative x squared. If x is larger than 0. One simple way to do this is you graph e to the power x. Oh, sorry. So you graph e to the power x, right? So how does e to the power x look like? Like that, right? That's e to the power x. E to the power x, we know it's domain and range, right? We know it's domain and range. So let me have it set up properly. Okay, so that's our e to the power x. What do we need for e to the power x? For less than or equal to 0. So we only need this piece. Do you follow me? We only need this piece. How about negative x squared? Negative x squared, right? We know how that works, right? It's just it's parabola flip over, right? So you have these 2 pieces. You have these 2 pieces. That's negative x squared. That's negative x squared. So I'm going to make some adjustments. Okay, that's negative x squared. So that's e to the power x. That's negative x squared. But neither one is the curve because both are defined on the whole real number, on the entire number line. So what do you do? What do we do? Okay, you put them together and you do some whiteout. Okay, you do some whiteout. So as simple as that. Okay, so if I put these 2 pieces together, let's see if I can do the whiteout. Okay, so then I'm going to put in my x squared. I'm going to put a negative x squared in the same picture. But never ever turn in something like this. Don't turn in this thing like this. You're going to get 0. Okay, what you're going to have to do is that your picture. Okay, so let me make a little bit more adjustment here. It doesn't look very good. 4 here. Okay, so what you need to do, you see when it's e to the power x, when x is less than or equal to 0. So these pieces need to be white out. I cannot erase it, and then this software cross it out. Okay, how about I just cross it out? Okay, cross it out. These are out. Do you follow me? When it comes to x less than or equal to 0, these are out. When it comes to x larger than 0, and this piece is out. So your curve is just this piece and the next piece. But it's very important that we take care of the endpoints. Okay, less than or equal to 0, so that 0 is included. So you're going to put a dot. You're going to put a dot here. Do you guys see that dot? And you're going to have to put a circle here, because on the negative x squared piece, you don't have the 0 is not included. So you have to have a circle. Hold on, I'm going to redo that circle. Okay, I'm going to redo that circle. I'm going to redo that circle. So this is the circle. So on your paper, I want you to take your eraser to erase this piece that I cut them out. I cannot cut them out right now. You guys see that? Okay, so erase this piece and erase that piece. This is a 2 pieces function. Got it? That's the 2 pieces function. All right, are we good? So this is a piecewise function. And number 4, I'm going to leave it for you. I think you can do it. Okay, same idea. They're all the same idea. Okay. So your curve should be nice and clean. Don't have that. Don't have that. Now, in terms of domain and range, domain for this function is really all real numbers. All real numbers. It's defined everywhere, right? Just different rules on different pieces. And range, you have to be very careful. Range, you have to be very careful, right? You can see on this piece, you have all the positive numbers up to 1. You have all the positive number up to 1, right? But you don't have 0. You don't have 0. So your range would be from here is negative infinity to 0, right? On this piece. So negative infinity to 0. So your range will have 2 pieces. Negative infinity to 0, not including 0, union, okay? 0 to 1, including 1, right? So this should be written, wait, sorry, not this way. Okay, I need a special symbol like that. So that's the range, and that's the sketch. You follow me? So that's the piecewise function over here. So when you observe the domain, observe the range, you have to be careful. Typically, the domain is all real numbers. It's defined everywhere. But the rules are different on different pieces. The rules are on different pieces. Okay, 49b is a reversal of this. Okay, you have function, you're given the graph and you ask to identify the function itself. Okay, you ask to identify the function itself. If you like, we can talk about this tomorrow. But these two questions, actually, I took them directly straight out of calculus textbook. Okay, I took them straight out. It requires some modeling, but I put it from B because I don't know why I put it for, I put it as a 49B. Why did I put it at 49B? I forgot. 50B, okay? 50B, every question in 50B, basic 50B, I would say almost every question is straight out of calculus textbook. 51A is where we are going to get to. Okay, 51A is where we're going to get to. I want to help you to get that 20, 30 points in calculus class. How to handle that absolute value. Okay, so that's all for today, and I apologize for being late for so much, and I really appreciate you guys stayed on with me and being patiently waiting for me, and no one messaged me even. Did anyone message me? No, I didn't have the phone. My phone was charging in my office. But anyway, I so appreciate it, but I'm glad we can make it up. And for those people who didn't get to make it for the extended period, they can watch the recording. But keep on deriving, keep on practicing. I will see you guys tomorrow. Thank you very much. Thank you.